Okay, I think we're ready now. So here it is, guys. Notes 14, Intro to Solving Trig Equations. Whenever it's a perfect coordinate, I would just use logic. I wouldn't bother with the equation. Excuse me. So it says, number one, solve the equation 2 cosine 3x minus pi over 6 equals square root of 3 on the interval 0 to pi over 2. So what you're trying to do is solve for x, guys. So what I would do first is divide by 2. So here we go. Cosine 3x minus pi over 6 equals square root of 3 over 2. And then from here, it looks like it's just the stuff that you guys have already been pretty accustomed to. You take the arc cosine of both sides. So you have 3x minus pi over 6 equals plus minus arc cosine of square root of 3 over 2 plus 2 pi n. Now, I know this is how we did it last time, guys, but whenever it's a perfect coordinate or a perfect radian like it is here, I wouldn't bother with equations. I would just use logic. So square root of 3 over 2, if you have a unit circle with you, you're going to need it for most of today because everything today is some type of perfect coordinate or perfect radian. So square root of 3 over 2 for cosine, that happens in quadrant 1 and in quadrant 4. So there's your plus minus pi over 6. But if you know what this is, might as well that's pi over 6 right there. And if we do that, that's 11 pi over 6. If you know what it is, just go ahead and just write it out, right? So equation number 1, 3x minus pi over 6 equals pi over 6 plus 2 pi n. Because every time I rotate another 2 pi from pi over 6, I'm going to be in the same terminal side. I'm going to be in the same ray. Equation number 2. 3x minus pi over 6 equals 11 pi over 6 plus 2 pi n. Now, I'm going to slow down. Have I confused anyone who's been here for a while? Have I confused anyone? Uh-oh. Guys?
What is the 2 pi n? Like, where does that come from again?
That every time I do a revolution, I'm in the same location. So if I'm here, that one in blue, and I do another 2 pi, I'm back in the same ray. Do we see that or no?
Yes.
Okay. All right, guys. Okay, Bada. All right, so from there, I'm going to go ahead and go back to equation number 1. I'm just going to solve. I'm going to add up these 2 pi's over 6's. So 3x equals 2 pi over 6 plus 2 pi n. 2 goes into 6 3 times. So 3x equals pi over 3. And probably I didn't have to rewrite it. And then what I'm trying to do is get x by itself. So I'm going to divide by 3, divide by 3, divide by 3, divide by 3. So I get x, or my x equals pi over 9 plus 2 pi n over 3. So pi over 9 is definitely an answer. I don't see it. I don't see it. Maybe, maybe, nope. So it's between C and D. So let's solve for equation number 2. Equation number 2 is right here. And I'm going to move that pi over 6 to the right. So 3x equals, when I add pi over 6 to 11 pi over 6, that's 2 pi. And I'm just going to divide by 3. And as you can see here, I get 2 pi over 3. 2 pi over 3 is larger than pi over 2. That's not in the domain. So the only answer is letter D, pi over 9. How do we feel, guys? Did we get lost anywhere?
No, we're good, Chav.
All right, awesome, awesome, awesome. Rubio, you doing okay? All right, we're good. All right, so this one right here, 6 sine squared plus 12 sine x plus 6 equals 0. Before I continue, guys, recognize that sine squared x does not mean sine x squared. Sine squared x means, I guess I'll put a semicolon there. Sine squared x means sine x and all that being squared. So why the difference? Because immediately after the end, you have a square there because it's sine that is being squared, not the argument, not the x. The x is not being squared. So notice the difference, sine squared x and sine x squared. So that's how you say it. That's the difference between both. I think we're good there now. Okay, next. This is similar to your algebra days. Chavez, what are you talking about? It's similar to this, guys. 6x squared plus 12x plus 6 equals 0. So when you had algebra 1 and algebra 2, you probably had that expression several times. And what would you do to solve for x or to solve for the zeros of this function? You would factor out a 6, and then you get x squared plus 2x plus 1. And then from there, you needed to factor out, right? So maybe you did the whole x thing, maybe you didn't. I'm not a big fan of that, but whatever. Whatever gets the job done. So the factors of this is x plus 1, and then put a square on the outside, and there it is. And then to solve for this, well, the only way that I'm going to get this to equal 0 is if x equals -1. And that would be the solution for that. It's very similar to that, guys. It's very similar to that. The only difference now, so we're going to do the same thing, but we're just going to factor out a 6 first. So we factor out a 6, and we're going to have sine squared x plus 2 sine x plus 1 equals 0. And then from there, once we factored that out, this 3 terms can reduce to one factor, to this factor, sine x plus 1 equals 0 with a square on the outside. And then we just solve for the inside, and we're like, all right, sine x plus 1, the only way that can equal 0, sine x plus 1 is if the expression equals 0, right? The only way this whole shebang will be 0 is if the expression sine x plus 1 is 0. Move the 1 to the other side, sine x equals a -1. And then from there, we can look at a unit circle. Yes, we can do arc sine, but look at a unit circle. And that happens here at that blue dot. That blue dot, if I go this way, that would have been 3 pi over 2. Notice 3 pi over 2 is not in any of the answer choices. That's because my domain is between -pi and pi. So let's see where -pi is and then go that way. So -pi would have been right here. That's clockwise, so there it is, -pi. So the green is just showing me starting at -pi and working my way towards pi. So -pi, boom, that one is a -pi over 2. Then I'm at 0, then I'm at pi over 2, then I'm back in pi. So there it is. I did a whole revolution, and it only seems that it only happens at -pi over 2. There it is. Malaya Pena, how do we feel? Pozos, how do we feel?
We feel good.
Yeah.
All right. What about you, Alaman? You feel the same way? Uh-oh. Is she not here? All right, Alaman. I don't know if you're here or not, but we're going to go to the next question.
Oh, she's not here, Chav.
Oh, she's not? Oh. What? Who's not here? Okay, that's fine. Let's continue. Give the YouTube video a thumbs up whenever you guys get to it. So we have this one. Solve secant 2x equals 2 on the interval 0 to 2 pi. And we're trying to figure out solutions that will get this, that will make that correct. We're trying to solve for x, right? So what I would do, guys, just do the reciprocal. If you come across secant or cosecant, just do the reciprocal right off the bat. So do the reciprocal of both sides. So the reciprocal of secant is cosine. So I'm going to write cosine of 2x equals a half. All I did was take reciprocals, guys. So now I'm ready. I'm trying to solve for 2x. So I'm going to do the inverse. So 2x equals plus minus arc cosine of a half plus 2 pi n. And if this wasn't the perfect coordinate, I would do the arc cosine of a half, just like I did the last time around. But this is a perfect coordinate, and I know what that is. Equation number 1. On the unit circle, cosine is a half in quadrant 1 up there and in quadrant 4 down here. So equation 1 is going to be 2x equals pi over 3, if you have your unit circle with you, plus 2 pi n. Equation 2 is going to be 2x equals, let's see, 3, 6, 5. So it's going to be 5 pi over 3 plus 2 pi n. So here we go. I'm just going to start solving for x on equation 1. Divide by 2, divide by 2, divide by 2. So x equals pi over 6 plus pi n. That's from the first one. And here we go from equation 2, divide by 2, divide by 2, divide by 2. X2 equals 5 pi over 6 plus pi n. All right, let's go ahead and see if we can get these answers here, guys. X equals, my first answer is going to be pi over 6. It wants between 0 and 2 pi. My second answer is going to be 5 pi over 6. My third answer is going to come from x1. Man, I can't even talk right. And I'm going to add pi to it. So put like a 6 over 6 like that. 6 plus 1 is 7 pi, so 7 pi over 6. And then my fourth answer is going to come from x2. Put a 6 over 6 for a common denominator. 6 plus 5, 11 pi. And there it is. Those are all of them, guys. And you probably could have figured it out by just going x1, pi over 6, adding pi, you're down there. Let's see, 5 pi over 6, you're in quadrant 2. Adding pi, you're down there like that. So there it is. How do we feel, guys? I just got the answers from x1 and x2. You see how I have right here pi over 6? So there's pi over 6 right there from the first one. And then this one right here, 5 pi over 6, that's from the second one. And then I just kept adding pi. See how it says pi n? I just did a denominator, 6 over 6. And then just 6 plus 1, 7, so 7 pi. And then 6 plus 5, 11, so 11 pi. Cool? Rubio, you doing okay? Malaya Pena?
I'm okay.
All right, I'm believing you, miss. Question number 4. So question number 4 says, solve sine pi x plus pi over 4 equals 1 on the interval -1/4 to 3/4. So again, we're gonna do the same thing, guys. Take out your unit circle. I'm gonna go arc sine, so pi x plus pi over 4 equals, arc sine does not have plus minus, so I do not want to see plus minus in front of that. If you want to be a robot, arc sine has this and then pi minus arc sine. But that'll be for another day. We're not there yet. I'm looking at my unit circle and I say, okay, where is sine equal to 1? It's equal to 1 where I have that blue dot. That happens at pi over 2 and pi over 2 only. So here we go. I'm going to write pi x plus pi over 4 equals pi over 2 plus 2 pi n. And I'll slow down. Remember, guys, what I'm doing, I'm trying to solve for x. So I'm going to subtract the pi over 4. Subtract the pi over 4. So this is like half minus a fourth. So if you have 50 cents and you take away a quarter, you have a quarter left. So pi x equals pi over 4 plus 2 pi n. And then the last thing I got to do to get x by itself is divide by pi. Divide by pi, divide by pi, divide by pi. So x equals 1/4 plus 2n. That 2n should not surprise you guys. The period of this right here is 2. Period is 2. In case you're wondering, Chavez, I don't know how you did that. 2 pi divided by pi gives you the period. 2 pi divided by your b. So that should not surprise you. I noticed that if I add 2 to the 1/4, I'm outside my domain. If I subtract 2 from the 1/4, I'm outside my domain. So the only answer is 1/4, and there it is. Rubio, any questions? Are you sure? Alcocer, any questions? You sure? All right. Ms. Juarez, any questions?
No, I'm good.
Yeah, if you add the 2n, it will go out of the domain. The domain is between negative 1/4 and 3/4. So that 1/4, if I add 2, it will be already out. All right, here we go, guys. Question number 5. We have 2 choices here, or 3 answer choices, A, B, and C. Usually when I give exams, you will not have 3 answer choices. I just got tired probably of typing these notes out. So inverse cosine, 9x equals plus minus arc cosine of 0 plus 2 pi n. But since we know that's a perfect coordinate, so we know this is going to be a perfect radian. Cosine is 0 up here in that first blue dot and down there that bottom blue dot. Remember, cosine is your x coordinate. So here's my equation 1. Equation 1, 9x equals pi over 2 plus 2 pi n. And equation 2, 9x equals 3 pi over 2 plus 2 pi n. And I'll slow down so you guys can catch up. We're trying to solve for x, guys. So we're going to get x by itself. Divide by 9, divide by 9, divide by 9. X equals pi over 18 plus 2 pi n over 9. That's from equation 1. I'm going to put a subscript on it. I go to equation 2, divide by 9, divide by 9, divide by 9. X2 equals, let's see, 3 goes into 9 3 times. 2 times 3 is 6. Pi over 6 plus 2 pi n over 9. And now I'm going to get answers. So what are my answers? Notice the domain is between 0 and 2 pi over 9. So if I have 1/18 of pi, that definitely is between 0 and 2 pi over 9. I cannot add 2 pi over 9 to it because it would take me outside the domain. So one answer is this pi over 18. And then 1/6 of pi is a smaller number than 2/9 of pi. So this is another answer. And I definitely cannot add 2 pi over 9 because that would take me outside the domain. So it looks like these two are my answers. So pi over 18 and pi over 6. We still okay, guys? Yeah, this room's a little warm. I don't know why. Let me grab some water. That was refreshing. All right, here we go. These are very popular. They're going to come out on your Delta Math on the level 1. So relax, they're not that extreme, guys. So you have cosine squared equals 1. So what you want to do, you want to get rid of that square there. So to get rid of that square, you're going to have to square root it. Square root, square root. So then you're going to have cosine x equals the square root of 1 is plus minus 1. You go to unit circle. And then you say, okay, where is cosine equal to? 1 and negative 1. It's equal to 1 and negative 1 at those 2 blue dots. And they're telling me my domain is between negative pi over 2 and 3 pi over 2. I'm going to label those. Negative pi over 2, I'm going to label them in blue first. Negative pi over 2 is right here. And if I do a complete revolution, I am back at 3 pi over 2. Does that make sense, Rubio? All right. So I'm going to start at negative pi over 2, guys. So I'm going to start it in green. So here it is in green. And the very first time, remember what I want to hit is these 2 blue dots. So the very first time that I have a solution is when x is 0. And then again when x is pi. And then when I come back to the 3 pi over 2, I'm done. And that's it. So at 0 and pi is where cosine is either a positive 1 or a negative 1. And I only look there because that's where I was told to look. If they told me to look between 0 and 2 pi, then it would have been 0 pi and 2 pi. Cool? Cool. Yay. All right, let's see what we got next. So on question 7, it says, solve the trig equation for all values between 0 and 8 for 2 cosine pi over 4x equals 1. And relax, guys. It's not that extreme. You're just going to throw a little bit of math life on it, and there it is, magic, and you're done. I'm kidding, guys. I'm trying to have fun here. But I wonder, does math type work on this? Or what is that app that you use to solve algebra? Mathway or... Oh, you guys know. Come on, guys. There's an app. Okay, there's an app somewhere.
Like photomath?
Yeah, photomath. Does photomath work on these? Probably
not. Do you want me to check?
Yeah, check. Check if it works.
Okay.
So I have this 2 cosine power 4x equals 1. I'm going to divide by 2. Cosine power 4x equals a half. We'll wait for Malaya Penna to tell us her verdict.
Yeah, I don't think it works. It just looks really, really, really complicated.
You don't think it works?
No, I don't think it works.
I'll try it out sometime soon and see if it works. Thank you, Malaya Penna. All right, guys. Equation 1. When I do the inverse of that, I guess I'll do it here on the side, right? Unit circle. You are half in quadrant 1 up here and in quadrant 4 down there. That's where your cosine is a half. And if you remember correctly, that's pi over 3 in the top. So I'm going to write pi over 4x equals pi over 3. And if I go another 2 pi, I'll be back in that same location. So that's where that's coming from. Chavez, how come we don't do arc cosine plus minus a half? Like I have done it, guys. But this is a perfect coordinate. That's why I'm just doing it this way. Equation 2. Pi over 4x equals, the one in quadrant 4 is, what's that, 3, 6, 5? 5 pi over 3 plus 2 pi n. Are we still pretty good?
Yes.
Awesome. So now I'm just going to multiply by the reciprocal, guys. Whatever you do to one side, you do the other. Multiply that by 4 over pi. Multiply all this by 4 over pi. Do the same thing with equation 2. That's a 4 there, 4 over pi, 4 over pi. And we'll get our answer. So I'm going back to equation 1. So here we go. I'm going to get x equals, the pi's cancel out, and I get 4/3 plus, let's see, 4 times 2 is 8n, so 8n. I'm going to call that x1. I'm going to go to equation 2, and I'm going to say x of 2 equals, let's see, pi's cancel out. 4 times 5 is 20, so 20 over 3 plus 8n. And there it is. My domain is between 0 and 8, so I'm not going to add 8 or subtract 8 for that matter. So my solutions are going to be 4/3 and 20 over 3. Cool or not cool, guys? Yay, I'm happy that we're happy, guys. All right, question 8. Solve the trig equations for all values between 0 and 16 pi for 2 sine 1/8 of x. I'm going to rewrite that as x over 8 minus 1 equals 0. So let me see. 2 sine, and I'm going to write that as x over 8 minus 1 equals 0. And there it is. I just rewrote it. A lot of authors have bad habits of not putting parentheses there, and that's fine. But I think we should start as mathematicians writing parentheses there. Let's move the 1 to the other side. So 2 sine x over 8 equals 1, divide by 2. So sine x over 8 equals a half. And now I'm going to do arc sine. So look at your unit circles again. Where is sine half on your unit circles? It's in quadrant 1 and in quadrant 2. So here's equation 1. X over 8 equals, my first radian where sine is a half is at pi over 6. So I'm going to write pi over 6 plus 2 pi n. Equation 2 is the one in quadrant 2. So I'm going to write x over 8 equals 5 pi over 6 plus 2 pi n. Look at your unit circle, guys. This one's a pi over 6. This one's a 5 pi over 6. Are we still okay? Rubio, you're doing all right? All right. So now I'm going to multiply by 8. Whatever you do to one, you do to the other. So here's my first equation. X1, I put a 1 in the bottom to indicate equation 1, is equal to, let's see, 8 pi over 6. I'm going to reduce it right now. Plus 16 pi n. 8 times 2. Let's see, let's reduce it. X1 equals 4 pi over 3 plus 16 pi n. All right, here's X2. Remember what we're doing, guys. We're multiplying by 8. So when I multiply by 8, let's see, X2 equals, that's a 4, that's a 3, 4 times 5 is 20. 20 pi over 3 plus 8 pi n. Plus 8 pi, plus 16 pi n. Disregard that. So my solutions, let's see, 4 pi over 3 is one of them. And you cannot add 16 pi because that will take you outside the domain. The domain is literally from 0 to 16 pi. Hey, don't fall asleep on me, Alcocer. I'm kidding, miss. Don't get mad. And the next one is 20 pi over 3. And there it is, guys. Does this wake you up? Do you get hyped? Yeah. No? Oh, okay. You're getting tired. No, miss, this is like an adrenaline rush. You don't need, okay, I'll stop. Question 9. Solve the trig equations for all values. Man, you know what I wish I had? I wish I had pyrotechnics. Every time we did a question, we had like flames coming out of everywhere. You know, like, if I ever own a church, I'm gonna have a whole bunch of pyrotechnics everywhere. And you know, we're gonna praise Jesus. Well, okay, you know, well, I'm sorry, guys. I didn't mean to bring religion into this. So here we go. So all the values between 0 and 7, square root of 3 cosecant 2x equals -2. So what you want to do is go ahead and divide by square root of 3. So you're going to have cosecant 2x, that's a parenthesis there, equals -2 divided by square root of 3. And what do you think, Malaya Pena, that we're going to do after I get it to here?
Find, okay, well, the 2x.
No, not yet. Not yet. We're going to take, it starts with the letter R.
Okay, find the reference angle.
No, not the reference angle. Second letter E. Well, I guess that doesn't help because it's like reference, right?
Yeah.
Third letter C.
Reciprocal.
Reciprocal. Perfect. Reciprocal. The reciprocal of cosecant is sine. So I'm going to write sine 2x equals a negative square root of 3 over 2. See? And then I go back to my unit circle. And then I'm just going to look where sine is negative square root of 3 over 2. That happens down here in quadrant 3 and down here in quadrant 4 because sine is the y value. So now I'm going to write arc sine. So you can do 2x equals, I'm going to call this equation 1. And that's going to be, let's see, 4 pi over 3 plus 2 pi n. And here's equation 2. 2x equals 3, 6, 5. 5 pi over 3, that's a 3, plus 2 pi n. Yay or nay, guys? Is that a yay? Okay. Next, I'm just going to divide by 2. Divide by 2, 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 divide by 2. So x1 equals, let's see, 2 goes into 4 twice. So 2 pi over 3 plus pi n. And then I'm going to go to equation 2 over here. X2 equals 5 pi over 6 plus pi n. And let me get my solutions. All of them between 0 and 7. So 2 pi over 3 is one of them. 5 pi over 6 is another. And then let's just keep going, and then we'll see if we need to delete or add. So I'm going to put 3 over 3 like that and 6 over 6 like that so I can add them. So here's coming from x1. 2 pi plus 3 pi, that's 5 pi. So 5 pi over 3. I think that's another. And then 6 plus 5, that's 11. So 11 pi over 6. And let's see, let me go one more from the x1. 5, 6, 7, 8. 5, 6, 7, 8. 8 pi over 3, and I think that one's not going to be in there. Okay, so which ones are between 0 and 7? So make pi, I know pi is 3.1415, and a lot of you know like the next 30 digits, and that's fine. We're going to just say pi is approximately 3 just so we can round here. That one's definitely in there because that's like a 2. That one's definitely in there. This one's definitely in there because that's like a 5. Travis, what do you mean it's like a 5? I'm saying this. 5 times 3 divided by 3, that cancels out. And it's like a number close to 5. This one, yeah, because if I put a 3 in there, that's 11. 3 goes into 6 twice, so that's like 5.5. So that one would be in there. But this one would not, because this one would be like a number, that would be like an 8. So this one's out. Let's take that one out. So it's these right here. Did that make sense? Rubio, are you sure? Malaya Pena, did that make sense?
Yes.
Juarez?
Yes.
Right. Juarez says yes, so that means we're good, guys. She's the boss. All right. Question 10. Solve the trig equations for all values between 0 and 2 pi of 2 sine squared minus 1. Excuse me. All right, so let's do that really quick. I'm going to move the 1 to the other side. So 2 sine squared x minus 1 equals, I said I was going to move to the other side, and it didn't move it at all. 2 sine squared x equals 1. I'm going to divide both sides by 2 to get sine squared by itself. So sine squared x equals a half. And no, don't do anything yet. We're going to take the square root of it because I don't want sine squared. I just want sine. So square root. Sine x equals, what this means, plus minus square root of 1 over square root of 2. So let's see what that means. So sine x equals plus minus 1 over square root of 2. Maybe you recognize it, maybe you don't. I'm going to go ahead and multiply by the square root of 2 over the square root of 2. So here's what that means. Sine x equals plus minus square root of 2 over 2. Looking at the unit circle, I'm looking between 0 and 2 pi. Where does sine x equal a positive square root of 2 over 2 or a negative square root of 2 over 2? And all the ones that have a denominator of 4. All of those. So I'm going to come back and I'm going to say x must equal all the ones that have a denominator of 4. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. How do we feel, guys? Arispe, is this making sense?
Yes.
Okay. And I'm listening, guys. I listened to y'all's advice. First period heard me. First period, I told first period that I was slowing down, and I'm slowing down with you guys as well. Notice I haven't started the next question yet. Yeah, I'm waiting for you guys. No, it's all good, miss. When you guys are writing stuff down, are you guys trying to pay attention to like what we're saying, or you just write everything down and pay attention later? Okay. Yeah, try to master the craft of trying to pay attention to what the logic is going on at the moment. I mean, I guess you can write it and try to figure it out later, but it's always best to just get it at that time, right? All right, we're doing the same thing for this one, guys. It's the last question. We're going to go slow. I'm going to move the 1 to the other side. 4 cosine squared x equals a 1. Then we're going to divide by 4. You're right, Rubio. You look like you're contemplating life, miss. Well, there it is. I divided both sides by 4. So now we have cosine squared x equals a 1/4. Next, we want to get rid of the square. So we're going to do square root. Cosine x equals plus minus square root of 1 over square root of 4. So cosine x equals plus minus a half. I think that one's pretty straightforward. Let's start looking at our unit circle. Cosine is a half. at all those radians. Those radians happen to have a denominator of 3. So pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Any questions, guys? What at the what? Oh, because the square root of 1 is 1. Let me go ahead and square root of 1 is 1. No, it's a good question. And the square root of 4 is 2. So when I'm doing, like, when we're doing square root of a fraction, you can do square root of the top and the square root of the bottom. Cool. Don't ever hesitate to ask any question. You can ask any question, guys, anytime. It's all good. How do we feel? Do we feel all right? All right, guys, let's come back.